Nice to see so many people here interested in the roadblocks and deployment strategies of trusted types. As said, I'm Sebastian, and this is joint work with my colleagues Lea, Philipp, Katharina, and Ben from CISPA. And first let me start with why we have actually done this work and a little bit of history about trusted types. In September 2017, Google engineers came up with a new mechanism to defend against client-side cross-site scripting. And quickly afterwards, already the first voices came loud that it might be very complex and very engineering heavy to actually deploy this mechanism. And still, Google continued their journey, and in May 2020, they actually added support for trusted types in the Chromium engine. 1 year after that, in June 21, Mozilla actually placed a formal objection against trusted types becoming a technical specification. So it already had quite some history regarding back and forth if it is now becoming a standard or not. And also in 21, we published work on the usability of a related mechanism, the content security policy, and because it is already a widely used and widely supported mechanism, they were not very happy with introducing breaking changes here, which is why we actually started working on, okay, let's check the usability of a not yet widely used mechanism, trusted types. And towards the end of this journey, actually during the rebuttal phase, I think, Mozilla changed their standard position to positive, so trusted types is now indeed becoming a technical specification, so it is actually relevant what we have done. Okay, but what is trusted types? As said, a defense mechanism against client-side cross-site scripting. And in those attacks, an attacker lures a victim into clicking on a prepared link in this case, and in the URL fragment of this link, there is a malicious payload. So the user gets this via phishing mail, clicks on it, and requests a resource from the server. And in this resource, there is a JavaScript snippet that actually takes the malicious payload from the fragment of the URL, such that it and adds it to the web application itself, such that it becomes, part of the application and has the same capabilities as a benign piece of JavaScript running in the application. So this evil script is requested and executed and can do now all kind of shenanigans because it has access to session cookies and it can issue state-changing actions, like in this example here, bank transactions. How can trusted types now defend against that? Well, in trusted types, as soon as you enable it via the content security policy, it is enforced that those dangerous JavaScript functions that are doing this string to code conversion can only be called with a trusted types object. And in the example that you can see here, there's an inner HTML assignment that needs to now be a trusted types object instead of only being a string. And to create those objects, you need to call the sanitizer that is responsible for creating those objects. Here, create HTML. However, if you have an existing application with thousands of lines of code, you don't want to touch every tiny invocation there. So there is actually the possibility of having a default policy which is automatically, as soon as there is a dangerous function called, calling the appropriate sanitizer. So for an inner HTML assignment, the create HTML sanitizer. If you are doing direct string to code conversion of JavaScript via eval, you call the create script sanitizer. And if you are programmatically adding dynamic JavaScript via URLs, you are calling the create script URL sanitizer. Okay, but what have we actually done now? Well, we first, before talking about the exact methodology, we needed to overcome some challenges, because in other studies, we could ask, for example, in the CSP study, we could ask the people about their horror stories of the deployment process in their company, which is not possible in case of trusted types because nobody's using it and not all browsers are supporting it. But still, we wanted to, or we think that everybody should be able to use those mechanisms. So therefore, we want to ask the average web developer how they, what challenges they face when deploying trusted types. Another challenge that we faced, because it's not widely used at all, we wanted to do a live coding task during our interviews. However, there are no examples how trusted types is used in the wild because nobody is using it. Still, we wanted to be as close to the real world as possible here, which is why we crawled the top 10,000 websites to see which are the most common used third parties, like advertisement vendors, analytics vendors, and so on. And we then chose, I think, 5 of those top vendors and actually used those third parties such that we have a set of third parties in our applications that are representing a broad variety of websites. Now that we had a targeted population and a nice close to real world application, we used that to conduct semi-structured interview with this live coding task, transcribed those interviews, and then analyzed in an open coding process those transcriptions as well as the screen recordings that we had from the live coding tasks. And with the resulting codebook, we were then able to identify deployment challenges and also strategies for trusted types. The first thing, or the first challenge that people need to overcome when deploying trusted types is you actually need to enable the mechanism via the content security policy. And here, especially during the pre-study, the participants already took a lot of time in actually enabling it, which is why we in the actual study added some code snippets and some skeletons there to ease the process and reduce the frustration of our participants. Another thing that the people quickly faced after enabling trusted types was that some of our third parties, specifically the Twitter widget, or X widget nowadays, was using a same origin iframe for the timeline. And because those iframes inherit the content security policy for security reasons, but they are not inheriting the sanitizer, within the iframe, there was a content security policy now that is enforcing the usage of sanitizers that are non-existent, and therefore everything goes boom here and nothing is working anymore. After the participants then overcome or ignored this issue, they faced the decision whether they should use a named policy, like the one that you have seen earlier, where you need to explicitly call the appropriate sanitizer, or if they want to use a default policy. And in our example, you actually had to use the default policy because we are using third party, and while you can change your own code, you cannot change the code that is delivered via your third parties. After that, they started creating those sanitization functions, which is actually the hard part, the heavy lifting of deploying trusted types. And for creating or sanitizing HTML, that one was rather easy for the participants because there are a bunch of third-party sanitizers out there. For example, DOM Purify or the upcoming Web Sanitization API. However, they still have problems because they are blindly removing all occurrences of JavaScript. And in case you are needing certain snippets in there, because your advertisement vendors actually require them to give you money, it's not very good if then your sanitizer removes them. For the create script URL sanitizer, the people or our participants did not really understand the underlying issue it tries to fix. They rather have used it as an allow list of allowed URLs for the application. And they implemented this with the JavaScript starts with API or with regular expressions. But the actual idea here was to defend against known bypasses of other mechanisms like JSON-P or open redirects, such that you can actually sanitize the get parameters of the URL. However, if you are using starts with or regular expressions, this does not really work. The biggest issue that the people faced was also the issue where even we didn't come up with a proper solution, sanitizing JavaScript. And sanitizing JavaScript is super hard. And even all sanitization ideas that the participants came up with were either not perfectly secure or super hard to maintain. For example, some used a hash-based allow list, which is horrible to maintain because as soon as one character changes that your advertisement vendor is using, the hash is not matching anymore and it's not working. And for others, other used, for example, allow lists based on abstract syntax trees, which sounds like a nice idea. However, Fuss et al. Have shown that you can actually create malicious JavaScript with the exact same syntax tree as malicious benign JavaScript. So also an allow list here is not working. Yeah, so how can we improve upon the situation? For the browser vendors, one of the takeaways here is that they need to work on the sanitization API and ease the sanitization of HTML, because we want to have certain snippets to stay in the sanitized HTML. Another thing is they should fix those inheritance problems by just inheriting not only the CSP, but also the sanitizers that are registered and at the application. For developers, if they want to use trusted types, they should actually think about the integration from the beginning and choose third parties with care. Because as it seems to be a common pattern for web security mechanisms, third parties are the blocking factor here. And if they are using third parties, they should use default policies because it very much eases the process. But also we as a community should do improvements here. We have seen during the study that most of the information sources available for trusted types are focusing on named policies, which cannot be used in the wild because of third parties. So we actually need to work on information sources that are reflecting what is happening in the real world, such that it is easier for developer to understand and adapt here. And we also need to work on tools and evaluate them such that they can help to deploy trusted types. Okay, what have we seen in the last couple of minutes? Well, there is a new security mechanism in the web that tries to defend against client-side cross-site scripting. And we evaluated that with 13 participants that took part in our coding interview. And with this coding interview, we were able to see a bunch of successful or not so successful strategies to deploy trusted types and a bunch of roadblocks. And with that, I'd like to thank for your attention and feel free to ask questions.